Hello everyone, in this video we're going to be talking about bitwise operators. Now this is the second part of our bitwise operators video. In the first part we talked about our AND and our OR bitwise operator. In this one we're going to be talking about shifting bits. So shifting bits right and shifting bits left. And you're probably unfamiliar with this, so to make a little bit more sense, I'm going to go into an example because that's usually the best way to try and understand how these programs and concepts work. So again, we're going to start off with our value. Let's say we're going to say let, and we're going to just call this one num, and we're going to set our num to 5. And we want to keep in mind our binary equivalent of 5. So it's important that you know your binary for this video also. So again, if you haven't watched our binary videos, I would recommend it. So just to fill you in, the number 5 is equivalent to 0, 1, 0, 1 in binary. And I'm just going to comment this out. So we've got this number 0, 1, 0, 1, right? So when we go and shift right or shift left, we're basically taking our number and we're putting it to the right or putting it to the left. And when we put it to the right or put it to the left, we have to cut off some of our bits. Our bits are our zeros and ones that we have here. So if you could imagine this number in a box, and if I tell you you have to move this number to the right or you have to move this number to the left, you have to cut off some of these bits. So you lose some of these bits and they get replaced by zeros. So again, this mightn't be making a lot of sense, but it will now in a second. So like in all our previous programs, how we actually see anything is we want to console log it. So we'll say console.log, and we're going to take our number, which is num. So this is our variable that represents our number 5, and we're going to shift it to the right. Okay. So to shift it to the right, we use two greater than signs, and then we say 1 because we want to shift it by one place. So for example, imagine we have this number here and we're shifting it to the right. So you can imagine this number here is going to be pushed to the right. So if this number is being pushed to the right, what's going to happen? Well, whatever number's on the end here, which is 1, is going to be separated. Okay, so 1 is going to be separated and then a 0 is going to be added on to the end here. We can think of this 1 here as just being deleted or disappears. So now we've got this number here, which is 0, 0, 1, 0, and this number here is equivalent to 2 in decimal. So if we go and run this, so let's say we go and hit run and run it out debugging, and we can see our number that we get here is 2. So what would happen if we didn't want to shift it by 1, we wanted to shift it by 2? So again, we're starting off a brand new program here. So we're going to go back to 5. So 5 is 0, 1, 0, 1. And last time we shifted by 1. So there was only one of these numbers taken away and pushed to the right. But in this scenario, we're going to be getting two numbers and we're going to be pushing them to the right. So we take two numbers, which is 0 and 1, and we push them to the right. And they basically get replaced then from two numbers that come in to the left. And them two numbers are 0. They're always 0. So again, we can imagine these two numbers here as being deleted or discarded. So if we go and run this now, we should expect to see whatever this number here is. So this number here in binary is equal to 1. So we should see 1 as our output. So if we go and just run this, we can see 1 is in fact our output. So that's our right shift, or some people call it signed right shift. Now if you get the basic idea with our right shift, our left shift should be pretty easy for you to pick up on. So we're going to convert this back to our binary number 0, 1, 0, 1. So that's 5 in binary. And this time we're not going to go with our greater than sign. We're going to go with our less than sign, okay? So we're going to just change this back to 1 because it might be a little bit simpler to understand at the start. So similar to last time while we were shifting right, this time we're going to be shifting left. So you could imagine last time where we got our first bit here cut off and it was separated. So similar to that, only coming from the other side. So our 0 is going to get cut off, and then 0 is going to be added to the right. So if we go and basically delete 0 because it's like it's not there, and we go and run this, we should see whatever number this is. Now you may or you may not know what this number is in decimal. I can tell you now that it's equal to 10, so we need to go and check to see is our output that we get actually 10. So if we go and run this, we can see that our output is 10.